let's calculate this character here. It's a character of S13, cycle structure, a 7-cycle, a 4-cycle, and a 2-cycle. So this adds up to 13. And the irrep is given by this partition, 6, 3, 3. So we have this Young diagram here. Now, when we use this recursive procedure, it's most convenient to choose a cycle to start with where you find only one skew hook. So for example here there's only one skew hook of length 7, and I think that's this one here. So we remove this skew hook and we look for the sign. So this is a skew hook with 2 vertical steps. It's an even skew hook, so we don't get a sign change here. And now we know that the character we are looking for is the same as the character of the remaining diagram, 2, 2, 1, 1, and cycle structure 4, 2. So it's a character of S6. And now let's say we remove a skew hook of length 4, and again there's only one, this one here. So what's left is just this 2-box diagram on top, and this is once more 2 vertical steps. We have 2 vertical steps here in this skew hook, so it's once more an even skew hook. Again, plus character for 2, 2, and now in the next step we completely remove the diagram. No boxes left, 0 vertical steps, so no sign change, and we found the character is 1. And it doesn't matter which cycles we start with in this procedure. So let's do it again. Let's say we start with a 4-cycle. There's also just one 4-cycle here in this, sorry, one 4 skew hook of length 4, this one here. So by removing the 4-cycle, we get the character of, what's that, 6, 3. It's a character of S9. The cycle structure, remove the 4, 7, 2. And in this case, we had just one vertical step. So we get a minus sign here. It's an odd skew hook. And now let's look for skew hooks of length 7. There's just one. This one here. And again, one vertical step. So it's once more an odd skew hook. And then in total we get another minus sign. So we come back to plus. And now we have the same as above. It's 1 here. The least elegant way here would be to start, I didn't show this, that was the 2-cycle, skew hook of length 2 removed. Least elegant would be to start with the skew hooks of length 2, because there are several skew hooks. But let's also try that. So where are the skew hooks of length 2? Here's one. Here's one. And here's one. So now we get a sum of 3 characters of S11. And now maybe in the next step, if we remove a skew hook of length 7, let's look. There is one here, I think. 1, 2, 3, 4, 5. Oops. 5, 6, 7. So we can remove this skew hook here. Now there is is there a skew hook of length 7 here? 1, 2, 3, 4, 5, 6, 7. This one. And here we have 1, 2, 3, 4, 5, 6. Ah, nonsense. That was not a skew hook here. The one at the end. Look, after removing what I suggested, we don't get a diagram. Hopla. So what we really wanted to remove here, skew hook of length 2, was this one. Now let's see, in this last diagram here, there is no skew hook of length 7. So for example, if we start here, we would have to go down all the way, or just up to here, but that's less than 7. So you don't find any with length 7. Means we don't get any more contributions from here. That's 0. And now we have to look for skew hooks of length 4. There is no skew hook of length 4 here in this one. There's just one here. So again, in the end, it's just one character. It's just this 1 here, which we find. And we just have to check the sign, that this also comes out correct. We started with this 2 skew hook, 1 vertical step, odd. Then we had this skew hook of length 7, 2 vertical steps, even. The last one had 3 vertical steps, so it's odd again. We get 2 minus signs and everything is fine.